this experiment, we're going to be talking about diffraction. Specifically, we're going to be using the diffraction grating that comes with the kit. So you should have two of them. One of them is 500 lines, and the other one is 1,000 lines per millimeter. And the way we're going to set up this experiment is we're going to take our case, our kit box, and then we're going to prop it up like so. So that way we have a little bit more room below where the grating is going to go. So the idea of the grating is that if you put the grating in front of the laser, so here's my laser light. I'm going to use the business card that comes with the kit to trace out the laser light. So here's my laser light. Right, so you can see it's a diverging beam, and one thing I want to do is I want to make sure it's focused. So I'm going to rotate the lens ring until I get a nice and reasonably small beam. There you go. So now I know I'm focused, or nearly collimated, depends on how you did it. And we're going to put a diffraction grating in here. And then what you see is, you'll see there's another small spots right here. Let's see, now you can see both. Now you can see the primary, the original beam, and the diffracted beam. And then you can see there's two diffracted beam, right? So as I move, so let me get rid of the detector out of the way first. You don't really need a detector for this experiment, so we could just put it out of the slot, so we got a little bit more room there. And let me put the business card back. So you could see the beam expands because it's being diffracted by the diffraction grating. And then the other thing you could see is, suppose if I put the card right here, the beam is somewhere around this neighborhood, right? So you can see where my finger is. And then if I change the diffraction grating to the other one, which is 500, and I keep my business card about the same place, you could see the beam diffract a lot less. And then also you could see a secondary diffraction, a very faint one. So this is right, so it doesn't diffract nearly as much. So one thing we learned right off is that the coarser the line, the smaller the diffraction angle, right? And then you do have an equation right here that describes that. Now what we want to do though is we want to measure it analytically to see how much angle you're actually diffracting. So what we want to do is we want to take the ruler, and out of the pouch of the ruler, and what we want to do is we want to insert the ruler into the slot. So if you put it in from the side and then wiggle the way in like so, eventually the edge of the ruler should be aligned to the center line, and then the ruler should be held in place, just because it's a fairly tight fit, right? And then when you put a diffraction grating in there, you should be able to see that your laser dot is at 5 centimeter or 50 milliliter, right? And then the other side, you'll see the same laser dot, right? It's just that there's no slot on the other side to hold the ruler necessarily for you. So, but you know, you could confirm that too if you flip this the ruler over to the other side. And then furthermore, you could also use, so this is slot F for the ruler, but you could also use the other slot E. So you insert it the same way and then just wiggle. And then in this case, you could see the laser line is right here, and the beam will be out of focus a little bit. So you might have to refocus the laser to get a finer beam. So right here. So your job is to, based on the equation given and based on the angle of diffraction. So to get the angle of the diffraction, you need to measure from how far away the ruler is to where the beam is on the ruler. So say, for example, right now the beam is somewhere around 8.5 centimeters or 85 millimeters. And now if you look at the side of this, the grating is conveniently placed at 0 mark. So, and the ruler is actually at 10 centimeter even. So based on this is one leg of your triangle, right? And then this is 8.5 was the other leg of your triangle. So you have to do some trigonometry to figure out what that angle is, and that's described in this equation right here. And hopefully with that you should be able to find out what lambda, which is the wavelength of the laser light, is, and see if that makes sense to you once you compute the laser light, right? And a little bit of a cheat is I tell you you could already know that the laser light is somewhere around 650 nanometer based on the warning sticker. So it's a giveaway, but the point is that you should be able to determine if this warning sticker is lying to you or not, right? Or how accurate can you get to the 650 nanometer? Maybe the laser is slightly off than 650 nanometer, right? So you should be able to determine that yourself, and then because you have another diffraction grating, you should also verify that as well. See if the science holds true for different diffraction gratings. So you should get a different diffraction angle out of that as well. So that's it for the diffraction experiment, and thank you very much. We'll see you on the next one.